Okay, ladies and gentlemen, we're now going to talk about a jumping frog. So the height in inches of a frog's jump can be modeled by the equation h of t equals 60t minus 75t squared, where the time after a jump is measured in seconds. So first of all, a couple things from this equation. I'm going to write it in standard form with the t squared first, so the highest power first, and then t, and then we're also going to put the constant term. So this would be negative 75 t squared, and then plus 60 t. And then if you notice, there's no plus 0. So there's no other constant term, so plus 0. So again, this would be our initial height. And then this 60t, this 60 would be our initial velocity. And then this negative 75t squared must be the effects of gravity. So if we're finding h of 0, that's saying if the input is our time, at time 0, we're going to see what the height is. So to find h of 0, we go h of 0 equals negative 75. And then I'm going to put parentheses to substitute in our 0. So times 0 squared plus 60 times 0. And then we can leave off the plus 0. So that seems like a big calculation. I'm going to actually I could have used a calculator, but as I looked at the equation, 0 squared is 0 and negative 75 times 0 is 0. And this is also 0. So it's going to be 0. And then I'm looking for units here. And I'm going to assume that the height is going to be measured in feet. So what we can say to answer that, what does that mean about the frogs? What do the values mean in terms of the frog's jump? So at 0 seconds, the frog was at 0 feet. Which basically, to put that in regular terms, the frog jumped from the ground. And then we have to figure what's the height after 0.8 seconds. So if I go h of 0.8 and plug that in, we would go negative 75 times 0.8 squared plus 60 times 0.8, and then see what we get. So let me clear everything out in there. So negative 75 times 0.8 squared plus 60 times 0.8. And it's also 0. So to say that again, at 0.8 seconds, it's also 0, and it looked like off, but it's 0 feet. So that means the frog was in the air from 0 seconds to 0.8 seconds. So how much time after it jumped did the frog reach the maximum height? Well, these two pieces of information told us our zeros. So we know that x is equal to 0 is one of our 0. And that x equals 0.8 is another 0. So to find the vertex, we find the average. So we go, all right, that's 0 plus 0.8 over 2, which is 0.8 divided by 2. If I split that into 2, it's 0.4 seconds. So to explain what we did, the zeros were 0 and 0.8. The x-coordinate of the vertex is in the middle. So the x-coordinate of the vertex is in the middle. So let's verify that. So I'm going to put that graph, y equals negative 75t squared plus 60t, into the calculator. And then I'm going to graph it. And looks like I got to change my window a bit. So the x max, I'm going to go maybe to 15 feet and then graph that. And then I'm also going to change the window. Oh, I should probably go from 0 to about 2 seconds. And then the y min, it started at 0 feet, and then I'm going to go to about 20 feet. See if we get a better look at there. Oh, that's strange. Looks like we're getting a little bit of glare there. And then you can see here, if we go second calculate, and if I go to the maximum, and then move to my left bound, can hit enter there, and then another enter, and it looks like it's at 0.49999, which is 0.4, like we said. So now, ladies and gentlemen, we're going to talk about a catapulted pumpkin. So the equation h equals 2 plus 23.7t minus 4.9t squared represents the height of a pumpkin that is catapulted up in the air as a function of time in seconds. So the height is measured in meters above the ground. The pumpkin is shot up with a vertical velocity of 23.7 meters per second. Without writing anything down, consider these equations. What do you think the 2 in the equation tells us? And what about the negative 4.9 t squared? So 2 is our initial height, if we remember back from our equations. So 2 is our initial height. And then if I'm looking at my units, it's shot off at meters per second. So this is actually meters. And then the negative 4.9 t squared, well, the subtracting and the t squared tells me gravity. So if we graph the equation, will the graph open upward or downward? Well, it should open downward because if I shoot a pumpkin up, it's going to go up to the air and come down. And then why? Gravity. So where do I think the vertical intercept will be? Well, the vertical intercept is a y-intercept. And looking at this equation in standard form, we can see that the y-intercept is going to be 2. So I'm going to put 2 and then my unit meters. What about the horizontal intercepts? I'm really not sure. So I'm just going to put question mark. I'm not quite sure about that. That's a wondering. So if I graph it, I can for sure find those. So that's what we're going to do. So we're going to change here to 2 plus 23.7 x, and then minus 4.9 x squared. Looks like I got to change my window. So I'm going to change my x min or max to 10, and then change the number of feet to like 80. We'll just see if that fits. And that definitely does. So if I look on my x-axis, I can go from 1, 2, 3, 4, 5 seconds. So I'm going to change my window. Instead of being to 10, I'm going to change that to 5. And I'm going to change this back down to be 40 and see if I get a better graph. That looks a little bit better. So we graph that. And then it says identify the vertical and horizontal intercepts. So I'm just going to sketch this graph. So we can see here, this was, the start was 2. And then on the x-axis, if I count here, we have 1, 2, 3, 4, about 5 seconds. So I'm going to put 1, 2, 3, 4, 5. And then there's my 0. And then we can find the vertex actually by pressing second calculate. And then if we go to the maximum, when it says left bound, we need to have the cursor to the left of the vertex. And then arrow over and have the other cursor to the right of the vertex. And in graphing that, we see the vertex here is 2.4 seconds and 30.66 feet if I round. So the vertical intercept to answer the question, that is my initial height. And then we have a horizontal intercept back here that doesn't make sense in terms of the domain. Here is my horizontal intercept. Which we said in this case is about 5 seconds. It's at 0. We can calculate that exactly if we go second calculate and go to 0. And then left bound, we just keep our cursor to the left and then arrow over a little further. And it looks like 4.9. So we can change that, be a little bit more precise, 4.9 seconds. But that is when the pumpkin hits the ground. And then our vertex, that's the highest point of the graph. So now we're going to talk about baseballs, another projectile motion graph. So here's a graph that represents the height of a baseball in feet as a function of time, t seconds after it was hit by player A. So as we look at this, here is our first graph. And then so this is a function, we're going to call it h of t. And then we have a second function, g of t, which is defined by negative 16t minus 1 times t minus 4, which also represents the height in feet after it was hit by player B. So without graphing the function, answer the following questions. So which baseball players which player's baseball stayed longer? So we can look at player A, and estimate about 5.1 seconds. And then we can look at player B, and we can solve these directly by getting the zeros. So for G of T, for player B, my two zeros would be negative 16 T minus 1. And we would set this factor equal to 0. Then the second factor, T minus 4, would also equal 0. So in solving this one, I would add 4 to both sides and get T is equal to 4 seconds. And then here, I could add 1 and add 1 and get negative 16T equals 1. Then divide by negative 16 and get T equals negative 1/16 of a second, which doesn't make sense in our domain because that would be going back in time. So this would be 4 seconds. So to answer it, which players stayed in flight longer? It'd be player A. So now, which players reached a greater maximum height? Well, from player A, we're going to have to estimate. So I'm going to estimate player A and estimate that height to be about 105 feet. And then player B, we can calculate. So we need to find the average of negative 1/16 and 4 to find the x coordinate of the vertex. So x of vertex is negative 1/16 plus 4, and then we're going to divide that by 2. So if I do that, I'm going to use my calculator and just take negative 1 divided by 16, and then add 4. And I got 3.9375. Divide that by 2, and I got 1.96875. I'm just going to round that to about 1.97 seconds. So x is about 1.97. Now, that's our second time. So we're actually going to have to plug that back into G to figure out our overall time. So we're going to say G of 1.97 is equal to negative 16 times 1.97 minus 1, and then times 1.97 minus 4. So putting that in, I go negative 16 times 1.97 and then minus 1. And I'm going to need to put parentheses around that. So if I press second insert and then put a parenthesis, and then multiply that by 1.97 and then minus 4, I got G of 1.97 seconds equals about 66 feet. So we'll put the approximate. So here it's about 66 feet. So we can see player A had a greater maximum height. So how can you find the height each was hit? We already talked about that. So for player A, you had to estimate. And then for player B, we use the equation